Hi Aryan, how are you doing?
Hi, I'm doing good. How are you?
Very good, very good. So after our class on trigonometry, I hope you must have been in a position to answer most of the questions from your book. Are you in that position or no?
Yeah, I was able to solve a good amount of the questions. There's still a few questions that I'm still a little bit like confused on how to do, but for the most part, I feel good.
Okay, so let's take up the questions which you still are not very clear about. But I'm
Yeah.
glad that you have picked up very fast. Okay,
Okay.
great.
Yeah, I put it in there. I also just organized the fold into like everything into folders so it would be easier to look for the right material.
Oh, that's very good. That's good. So let me just see. Math 3. Oh, you organized. Okay, so this is trigonometry and trigonometry graph.
Yeah, we're doing graphs, so trigonometry was the last unit.
I see. You're doing graphs. Oh, that's beautiful. Oh, yeah. Good. So there were earlier so many files to look at. Now we don't
Yeah,
have.
yeah, that's why.
So now let me share with you the file.
Yeah, it's called Graphing Quiz Review Sheet.
So graphing sine cos applications. No. Gra- Which one? Graphing? Can you see my screen?
Yeah,
Which one? Tell me.
yeah, it's the Graphing Quiz Review. It's right above that. Right above that. Yeah,
Graphing
that one.
quiz review. Okay.
Yeah,
Okay, great. So that's the one which you want. Perfect. So this is graphing trig functions and applications worksheet. Omega. Wow. Good. So let's work on this and see how we can solve some questions. Okay, let's begin with the very first one. It is a very interesting question. So Aryan, can you please read question number one? Let's work on it.
yeah. In a predator-prey model, the predator population is modeled by the function p is equal to 900 cosine 2 pi over 3t plus 8,000, where t is measured in years. Find the length of time between successive periods of maximum population.
Mhm,
Sketch a graph that represents the given population model,
mhm.
and what is the minimum population, and when does this occur in the first cycle?
In the first cycle. So, okay, that should be a straightforward. Can you help me answer these questions? Let's begin with A. Find the
Yeah.
length of time period between successive periods of maximum population, right? So, this is a cosine function, right? So, cosine starts with t equals to 0 with maximum. Do you see that? So, we have a cosine function, right?
Yeah.
Cosine starts with maximum.
Yeah. Yeah. So,
Since there is no phase shift, right? Since there is no phase shift, it starts with maximum, correct? So let me sketch this function here itself, a big and bold. Okay, not bad. So we have this function here. Since 900 is the amplitude, right? So from the given values, what we have here is this is my axis, correct?
yeah.
So axis is given to us as 8,000. Perfect. The maximum will be, you have to add amplitude to it, right? So we'll add to this 900. So when you add 900 to this, what do you get? You get
We
8,900,
8,900. Yeah.
right? And when you subtract this, you get the minimum, right? So so you do, this is 900, right? So you have to go down 900 this time. So what do you get? 7,100.
7,100. Yeah.
So that becomes your minimum. Now we are talking about the time period t. So when it says that the k value is equal to 2 pi by 3, from here we can find the time period, right? T. So time period is 2 pi by k, which is 2 pi by 2 pi times 3. So it is 3, right? So If I sketch this graph with the axis, we have the y-axis starting like this. Correct. So I'll break this here, right? So, and I'll draw this. When I do that, I know that one cycle is 3, and this time is in years.
Yeah.
And the number is in what? Just numbers? Okay,
Uh-huh. Yeah.
numbers, right.
It's years and years. Yeah.
So this is just numbers. Let's write n, numbers.
Okay.
Correct. Find the length of time between successive periods of maximum population. So it is 3, right? So it begins with maximum, and after 3 years, it will be again 3, a maximum. Clear? So first answer is 3.
3 years. Yeah.
B. Sketch the graph that represents the given population model. So let's write down
Yeah.
this as the population with time t, right? So let me rewrite.
Yeah.
Correct. Population time t in numbers. So we've done this
Yeah.
part. What is the minimum population? When does this occur? In the first cycle.
First. Yeah.
So this is occurring at 1.5, right? Half the time.
Yeah. Yeah.
And minimum population is 7,100
Yeah.
after 1.5 years. Is that clear to you?
Yeah. Yeah. That's good.
Very good. Now, with this question, normally what we do is, let's say we can take predator as, let's say, wolf, for example, correct? So in that case, we could combine this with deer population. And then, we can see how the two graphs match one another. Because if the wolf population is increasing, the deer population will be decreasing, correct?
Yeah.
And when the deer population is very low, wolf population will start decreasing because they don't have enough food to eat. So these cycles
Yeah.
of decrease and increasing for wolf and for deer in many examples can be studied, and they have been studied, and those graphs have been plotted. And from these graphs, we can actually find the health of a forest. You get the idea?
Yeah.
Sustainable. So we should have these regular cycles so that it's sustainable. Perfect.
Yeah. Yeah.
Okay, great. So can I clear the screen? We can move on to the next question now, right?
Yeah. That's fine.
Can you please read the next question?
Yeah. A variable star is one whose brightness alternately increases and decreases.
Mhm.
For the variable star Nini Minor, the time between periods of maximum brightness is 5.4 days. The average brightness of the star is 4.0, and its brightness varies by a magnitude of 0.35. If a champion major is at its brightest at t is equal to 0, find a function that models the brightness as a function of time.
Okay.
At what point will the star be at its dimmest, and what is its magnitude?
Yeah.
And what is the magnitude of brightness after 2 weeks?
Correct. Very. So we have brightness and then this, and let's read it once again to sketch our graph directly, right? A
Yeah.
variable star is one whose brightness alternately increases and decreases. For the variable star Nitani minor, the time
Yeah.
between the periods of maximum brightness is 5.4 days, right? So in so many days, one cycle is completed. The average brightness of a star is 4, and its brightness varies by a magnitude of 0.35. The average value is given to us. So the average value is given to us as 4. And its brightness varies by a magnitude of 0.35, means it could go up by 0.35 or down by 0.35. You get the idea?
Yeah.
So So in that
Yeah.
case, we have this value here as 4.35 as maximum. And what is 4 minus 0.35? How much do you get?
You get 3.65.
Correct. So 3.65 becomes your minimum. Now, a champion major is at its brightest at t equals to 0. So brightest, that means you start with the maximum, like a cosine function, correct? You see that?
Yeah.
Clear?
Yeah.
Find the function that models the brightness as a
As a
function
function.
of time. So this is time for us, right? So let me just draw roughly the axis here. Let me break the axis because I'm not making it to the scale at all, and we'll work in this area. Now, we also know that one particular cycle is basically 5.4, right? So half of this is how much? 2.7, correct?
2.7. Yeah.
So we have sketched our graph. Do you see that? You can do half of this also. You get this point, and then multiply by 3 to get the next point, correct? So you have all
Yeah.
these points. Perfect. So the graph is ready. We know this is brightness. You can say brightness B, right? With time t, correct. And t is in days. Perfect. So brightness as t equals to 0 is shown here. This graph is made. Is it clear to you?
Yeah. Yeah.
And the function. Can you please write down the function for this?
Yes.
So amplitude
Here.
0.5
Yeah. 0.5.
cos of the k value.
The
So
K value is wait,
the time period is given to us as 5.4.
5.4.
K
Yeah.
is 2 pi by 5.4, right? Correct? So it is
Yeah.
customary to write this without decimals, right? So you could
Yeah.
think about this as 20 pi over 54, right? And now you can simplify this. Is that clear to you? So it's good
Yes.
practice to write this as 10 pi over 27, correct? So we get here 10 pi over 27. There is no phase shift since we are starting the cosine function with
Yeah.
maximum. And we have 4 as the axis, plus 4,
Yeah.
right? So you can write 4.0 you want.
Yeah.
That becomes the equation, correct? So we have the
Yeah.
equation also with us. Now the question is, at what point will the star be at its dimmest? What is the magnitude? Oh, that we have already answered. It is
Yeah.
2.7, dimmest value is 3.65, right?
Yeah.
What is the magnitude of brightness after 2 weeks?
2 weeks.
So you
Yeah.
have to convert days and weeks, right? So that means 14 days, correct?
14 days. So what do we just plug it into the equation?
Yes, just plug it
Yeah.
in, get the idea. So let me write down. B 14, right? So convert weeks to days equals to 0.35 cos of 10 pi times 14 divided by 27. That's how
27.
you calculate, right? Plus,
Yeah.
right. How much you get?
Yeah, I'm putting it.
Okay. So
Or 0.045.
okay, so that's okay. Let me rewrite this
Or
equation.
6.
So I'll
Yeah.
rewrite this equation as we are finding this as equals to 0.35. You clear your screen, do it once again. Let's do that practice now. Cos
Okay.
of, I'm multiplying this and writing this as 140 pi divided by 27. Do you see how you have to type in the equation? Plus 4.
Yeah.
Now you tell me what value you get.
Yeah, that's why I typed that's how I typed it
Yeah.
in.
Otherwise, you'll make a mistake. If you type right,
Yeah,
it's fine.
because on the calculators, like whenever you put like let's just say you put like pi over 6 times 2, it's gonna be like pi over
Yeah, yeah.
12 because like the
Pi over
denominator.
12. Right, right. That
Yeah,
is why
it's
you're getting wrong answers sometimes. So write like this. All multiplication, then you slash divide. You get that?
okay.
What do you
Yeah,
get? Tell me. 3.70. Sorry. This answer should have been 3.707. Because you see, the value I'm getting is less than 4. Do you see my graph?
yeah,
So that is why I recalculated. That is what you get. So your answer should be 3.7075. You can round it to 3.7 and write down your answer. Two decimal places will be okay. So 3.71 will be a correct answer for it. Is that okay?
yeah.
Now, when you sketch, you will get fairly good idea of the value also, because on this proper graph, you can read the value, right, at 2? And then that should confirm with your calculation. Perfect?
Yeah,
And if it is not matching, recalculate. Because sometimes radian measurements calculations, you get an error. Perfect.
yeah.
Great. So we're done question number 2 also. So with this, we'll revise, kind of review what
Okay.
we learned. So let me clear the screen now. And yes, so Aryan, can you summarize our today's learnings?
Yeah, so we went over some problems, some word problems using sine and cosine, and just once again just visualizing how our graph is going to be, and we didn't really have to do much because in the word problems we were given most of them like things like things we need to just like make our equation and solve. So we did some word problems and then we moved to like even like and then like even more complex word problems while just making out our graphs and finding what we need to find when asked.
So whenever you have a word problem, I'll recommend that read it twice. Once you
Yeah,
read it to get the whole idea and a picture, visualize what exactly it is, make a rough sketch on the side. Once you have a rough sketch, then you again read it. While reading, place all the values given in the word problem on your graph, right? So you have all the values set there. Then you start working on it. So first thing is, first draft reading should be related to your visualization. Make a sketch. Then again, read it carefully. Mark all the values given, maximum at this time, that much, minimum at this time, this much, right? And what do you need to figure out? So once you have these things in mind, then
yeah,
you start working on it. It'll be very easy, just as
yeah,
it was in this case, correct?
yeah.
Perfect. So we'll end our class here today, and I hope you are able to do more and more questions with this. Feel free to share all your questions with me. Okay. Thank you.
Okay, yeah. Thank you very much.
All the best.
Have a good evening.
You too. Thank you.
Bye.